Now let's think about these numbers that are whole numbers taken to an exponent versus fractions taken to an exponent. Like we were looking at in the last couple of examples, or the bacteria and the ibuprofen. So, okay, here's a table and it says complete the table based on the pattern. What is the pattern? Okay, from 2 to 4, I see a double. From 4 to 8, I see a double. Okay, so I see that. Okay, I did it again. I have another page under this. Okay, double, double. Okay, and so this one had 2 to the first power. This is 2 times 2. So 2 times 2 is 2 squared. And this started at 2 and did 2 times 2 times 2, which is 8. Okay, I'm going to fill in everything possible right now. Here we go. If I go down and double again, I get 16. That would be 2 to the 4th because I just took this 2 and multiplied it by 2, by 2, by 2 again. But if I go up here, I have to have a number that number times 2 will get 2. And that number is 1. 1 times 2 will get a half. So it's almost like I was, if I'm going up this, right, I'm taking half of it, half of it, half of it, half of it. So doubling on the way down, but if I'm going up this chart, I'm splitting it in 2. So half of 2 is 1, half of 1 is 1/2, half of a half. So 1/2 times 1/2 is a quarter, or half of a half is a quarter. If I take each one of these quarters and split each of them into 2, now there are 8 pieces, so an eighth. If I take each one of these and split them into 2, now there are 16 portions, so 1/16. Okay, so there's the pattern. And you could double check, right, that on the way down. So if we take, let me zoom out to get the full calculator. If we take 1/16 and we multiply it by 2, because going down this chart, we multiply by 2, we get 0.125. Oh, is that 1/8? Well, you could either type in 1 divided by 8, or you could go math, hit enter where it says fraction, answer to fraction, and voila, it shows 1/8. Here, let me, boop, there. Yeah. Okay, so going down this doubling, it will follow that pattern. So now what's happening here? So this is 2 to the 4th. 2 cubed is 8. 2 squared is 4. 2 to the first power is 2. And if I follow this pattern, this is 2 to the 0. And I feel uncomfortable with zeros. So again, I'm going to go 2 and then to the exponent of 0, enter. And it validates me. So thank you, calculator, for checking my answer. And if I notice this pattern, right, not only are we seeing this, but also we're going 4, 3, 2, 1, 0, and then it's counting down. So 2 to the -1, 2 to the -2, 2 to the -3, 2 to the -4. And just to double check, I'm going to again. So I'll go 2 raised to the negative. And by the way, you need this negative because it only likes that. 2 to the -4th power. I'm going to hit enter. Okay, thank you very much. So now I'm going to go math, hit enter where it says answer to fraction, and hit enter, 1/16. Yeah, so 2 to the -4 is the same value as 1/16. And then if we look at this, in terms of these and going, as this is a half to the first power, a half squared. Is that true? Okay, parenthesis, 1/2, parenthesis, to the second power. 0.25 is a quarter. Yep. So this really is 1/2 squared. Oh yeah, because I took half times a half. So there's that. And then I took 1/2 times 1/2 times 1/2 to get to 1/8. So that is 1/2 cubed. Ah, so new pattern. 1/16 would be repeatedly taking halves or multiplying by a half, but that took 4 of them. So half, 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 half. Got it. And so if I'm following this pattern, this would read, okay, 4, 3, 2, 1. A half is being multiplied. Okay. No times. Just to double check. 1/2 raised to the 0 power. Yep. 1. That's value. Okay. And then let's continue that pattern. So 4, 3, 2, 1, 0. A half to the -1. A half to the -2, 1/2, to the -3, 1/2, to the -4. Huh. Let's see if that matches. So let's take 1/2. 1/2. Okay. Raised to the -4th power. 16. Okay. So, interesting. So these negative exponents, they're doing something. Like they're taking 2 to the -4, and that turns it into 1/16, which is the same as 1/2 to the 4th power. So it's an interesting relationship between these negative exponents and how they're being represented in terms of, are we multiplying by a half or are we doubling along the path? Are we going up or down? Oh, wait, are we going up or down? So here, if we're doubling all the way down, right? Okay, that means we are going further into positives. But if we're going this way up the chart instead of down the chart in order of numbers, so if we're going towards bigger positives with our counter, then they're going more positive. And if we're going like this, it's like we're going in the opposite direction and it's counting down in exponents. Oh, very, very interesting. Okay, so what is the pattern? Complete it. We did. We had some doubling on the way down. So we did 2 to the whatever powers. And if you were looking at going up the chart, it really looked like you were taking half or dividing by 2. And that did, like, it had the opposite effect on the exponent. Cool. Using this pattern, how much is 2 to the 4th? 2 to the 4th. 2 to the 4th is equal to 16. Which, by the way, is 2 times 2 times 2 times 2 times 2 times 2 times 2. How much is 2 to the -4th? Up here, 1/16. And we even check that on the calculator. And then how much, what is the value of 2 to the 0? 2 to the 0 is equal to 1. Okay, you didn't do any doubling, just steady. Okay, so this kind of indicated you doubled 4 times. Double, 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 16. This indicated you split into 4 times. Split, 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 split. Yeah, I did it right. Okay. And so that cut it into 16 portions instead of scaling up, scaled down. And then this meant you didn't scale up or down. It just stayed steady as it is. Okay. So let's do this next chart. It says, what is the pattern? Okay, let's find it. Divide by 3, divide by 3, which I remember. Oh, these are typos. Oh, man. Those are carryovers from this chart, I think. Look, oopsies. Right. So I have to get out my trusty whiteout. And okay, that shouldn't be there. Those are accidents. Sorry about that. Okay. Right. So new pattern, not an accidental copy and paste of the last one. New pattern looks like, well, 9 divided by 3. So 3 times 3 makes 9. So if I go up the chart, hold on, if I look at it like this, triple, triple. If I look at it like this, I'm taking a third. Take 9 and split it into 3 or divide by 3, however you want to view it. Yeah. Okay, so now that I have the pattern, so now that we've done this, it says complete the table. Sure. Let's do it. 27 times 3. I think it's 81. Here we go. 27 times 3. Triple it, 81. Got it. So 81. And that would be, so 3 got tripled. Yeah, so we've got a 3 to begin with. 3 times 3 makes 9. 3 cubed makes 27 because we tripled it again, and we have to triple that again. So 3 to the 4th power. Got it. And then as we go down, we're taking a third of 3, or what tripled would be 3. That's 1. A third of 1 is 1/3. A third of a third is 1/9. And if you're like, what? So let me go into fraction land and do, okay, 1/3. Got it. Arrow over. And then let me go back into fraction land, hit enter, and no, delete. Right on. It actually let me delete it. There. Okay. Times. Math, go into fraction land, hit enter. 1/3. Okay. I said a third of a third of is a ninth. Oh yeah, definitely. Now that I see it written like that, a ninth. Okay. A third of a ninth is 1/27th. And then I notice 1/81st. Okay. And if I match this pattern, 4, 3, 2, 1, this would be 3 to the 0 power, 3 to the -1, 3 to the -2, 3 to the -3, 3 to the -4. These negative exponents mean these are portions or fractions if our base is 3, or if we're taking 3 to some power to that exponent. Okay. And now, oh boy, I have typos. This chart tricked my mind. That is definitely not 2 to the 1st. 1/3. So this should not be there. It looks like this should have been copied right here on accident. 1/3. That is to the 1st. Okay. Sorry about that again. And if I'm looking at this pattern, 1, 2, 3, this would be 1/3 to the 4th in this last one. Let's double check. Right. So I'm going to go into fraction land. Oops. Enter. You know what? I want parentheses. 1/3. And then a parenthesis. And that is all to the 4th exponent. 1/81st. Yeah. Right on. Okay. And then this would go 4, 3, 2, 1. 1/3. Not powered up or powered down. Okay. 1/3 to the -1. Following the pattern, 1/3 to the -2, 1/3 to the -3, 1/3 to the -4. Okay, so what does it mean to be a third to the -4? Well, it's like saying you did the opposite of taking 1/3. Well, that's like the undoing of taking a third is tripling. So the undoing of this taking a third is doing this tripling. So that's what the negative means here in the context of the situation. I'm going to copy and paste this and change my exponent to -4 just to double check. There you go. Yeah, right on. Complete the table based on the pattern. Check. How much is 1/3 squared? Well, 1/3 times 1/3 is 1/9. So we can fill that in. Okay, so 1/3 squared is 1/9. Also, by the way, interesting is that is also 1/3 squared, or even 1 squared. 1 squared is 1 and 3 squared is 9. But anyway, this is what was really asked. It's 1/9. 1/3 to the -2. Well, it's the undoing of splitting into thirds, so it's tripling. So that's actually equal in value to 3 squared or 9. So so while I'm writing this, maybe it would be a good idea to even say that this is equal to 3 to the -2 power, just to make that connection. 2 was 1/9, and do it here too. So 1/3 to the -2 power, right, was equal to 3 to the 2nd power, which is equal to 9. And maybe I'll go up and do that too. Here, when we did 2 to the 4th, right there, that was also equivalent to doing 1/2 to the -4. So it's almost like this reciprocals what it's taking the exponent on. And 2 to the -4 there is equal to 1/2 to the 4th. 1/2 to the, oh, look at that relationship between the exponents and what we're taking, but they're all equal in value. Ooh, cool. 1/3 to the 0 power, not scaled up, not scaled down. That is just itself. Okay, it said, oh, there's a number 5. Simplify the following. Okay, let's do that. So now I'm looking at those relationships from that chart and what we just saw, and I'm thinking 5 to the -2 looks similar to this 2 to the -4, but it's a 5. So this will be a 5th, and it's here we have a -4. So, but we have a 2 in the other problem. So this will be a 2. So this is going to be equal to 1/5 squared, or 1/5 times 1/5, which is 1/25. Got it. What about this fraction to the -2? Do I see an example like that? Like this kind of? 1/3 to the -2 ended up being 3 to the +2 exponent. So 1/5 to the -2 will be take the reciprocal of that 1/5, and I get 5 to the positive square. So undo the portioning, and it's scaling it up. Scaling it to 25 times bigger. Okay. Does it look like it's mildly out of focus? Anyway, there we go. Much better. And then, ooh, what about this then? Yow. So this is, well, 5 to the -2, we said that that was 1/25. Yikes, look at that. A fraction inside of a fraction. Ew. So this is 1 divided by 1/25, which is equal to 1 times the reciprocal, which is 25. And that is now 25. That's equal to, oh my goodness, 5 to the +2. So this is 25. But notice when we had a 5 with a negative exponent in the denominator, it pulled it up out of being a fraction or portions and made it into a positive exponent. Interesting. Okay, so what about here? So I see this relationship now between these negatives, putting them into the denominator. So like this would be 1 over 5 squared, right? So 5 to the negative 2 is the same as doing 1 over 5 squared. So let's use that here. 3 to the negative 2 would be like putting 3 squared in the denominator, like here. But this 3 to the negative 5 is more like having a 5 to the negative 2 in that denominator, and that pushed 5 squared out of the denominator. So this will be 3 to the 5th out of the denominator, which means it's in the numerator. So we have 3 to the 5th divided by 3 squared, or 1, 2, 3, 4. Okay, 3 to the 5th divided by 3 squared. Okay, I'm just doing this. You could do it on the calculator if you like, which ends up being 3 cubed, or 3 times 3 is 9. 9 times 3 is 27. Huh. Cool. Okay, well, now what's going on here? So this part says, let's push it into the denominator as, okay, so 2 to the negative 10 would look like 1 over 2 to the 10th. And then this is 2 to the 7th, but I'm going to make it look like this to make it really clear that that's in the numerator, just to specify. So here's what I see. I see 2 to the 7th over 2 to the 10th. So 2 is being multiplied 7 times. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, and 10 times. Oh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Got it. Okay, so I am going to divide away 7 of these common 2's. Divide by 2. So this creates 1. 2 divided by 2 is 1. 2 divided by 2, 2 halves is 1. 2 divided by 2 is another 1. 1, 1, 1, and 1. 1 times 1 times 1 times 1 times 1 times 1 times 1 is 1. But then in this denominator, it looks like what I'm left with is 2 times 2 times 2. There's still more, which is 8, or 2 cubed. Huh, look at that. Or if you want, 1 over 2 cubed for that, just to make the connection between this negative 10 and this 7. But the big thing that I want us to notice is that, let's see, is that movement between, and the paying attention to the positive and negative exponents, along with if they're portioning or if they are scaling up, so doubling or tripling or whatever. So here's what I'd like to say. Negative exponents represent repeated portioning. And that could also, by the way, be represented through repeated division. And more values and moves. And sorry about that. And moves values, not more. From the numerator and denominator and vice versa. Moves values from numerator to denominator and vice versa. And I mean, for example, this 3 to the negative 2 ended up being portioning by 3 2 times. So it went from the numerator down to the denominator where it was represented as 3 squared. And vice versa. Same with this 3 to the negative 5 moved up because it was undoing a scale down into a scale up or triple. Okay, and then I want to also, I think that it is also remarkable that negative exponents do not make number values negative. Number which is pretty remarkable, actually. Here, whoop. Yeah. I mean, like this 5 to the negative 2 power, it didn't turn into a negative number after we computed it. So negative exponents do not make number values negative. They mean they're being portioned. So they're really about that, okay? That portioning up, portioning down. Now, since so at here I wanted us to look at patterns of these negative exponents and positive exponents, but this section also deals with scientific notation, and we still have that problem where we had this crazy answer that we haven't figured out yet. Yeah. So, but one thing we did was this remark: repeated division is represented using exponents too, but with fractions or opposite exponents. So this really means negative exponents can be used to show repeated division. But we still have yet to figure this out. We'll do that in the next video where we take a look at scientific notation.